Hello everybody. So I want us to tackle an example problem today. And you'll sort of see why I said like at a point in time Thermo is just a big math problem. It says the fundamental state law and entropy representation for some gas is given by this, right? S is equal to this, right? Where U is the internal energy, V is the volume, N is the number of moles of the gas, and R, A, B, and C are constants. Determine the expression for the following relationships, and we're just gonna do one in this video. They said define P as a function of T, V, and N. So pressure as a function of T, V, and N. Now what I always want you to do if you're sort of stumped is start off with the fundamental first law and second law combined, right? So that's what that says, right? And I'm gonna go ahead and solve for ds simply because I see an s here, okay? So I'm gonna say that ds is equal to du over t plus p over t dv. And I sort of forgot something actually. There's something we call chemical potential. Based on where I put this video, I don't really know if I've talked about it yet. This is called chemical potential, and this is simply the number of moles. And this summation just says like from I guess you can say from I equals 1 to like k or something, right? So all of the mu's added up and all of the n's and everything, that's what that would give us. So this would end up being minus the summation of mu I over t, I equals 1 to k, dni. Yes. Now, they're asking me to find p as a function of t, v, and n. I can see my p right here, meaning that if I can differentiate this s with respect to something to get this p, I'm in luck because I'll have to just take the differential of this s and differentiate it with respect to something to get p, right? Cool. So I'm going to go ahead and say that del s del v, this should actually be capital V, at constant, to make this go to 0 and this go to 0, I have to put it at constant u and at constant n, right? That whole thing is equal to p over t, right? Meaning that if I differentiate this whole thing with respect to v holding u and n constant and multiply it by t, I'll get p as a function of t, v, and n, right? Cool. Okay, here's what we're gonna do. So I'm just gonna write this to the side here. Del S, del V at constant U and N is equal to P over T. Cool. Now, I'm gonna go ahead and say that, maybe it's in a different color. I'm gonna go ahead and say that del V, I don't know if this is the correct notation, so forgive me if it's not, but I'm gonna write it anyway. Actually, this is gonna be pretty long, so let me just move it to the left a little bit. But del V at constant U and N of S. So I'm just gonna go ahead and write this whole thing. And I'm gonna go ahead and distribute this to each term, okay? And I'm gonna go ahead and separate these natural logarithm terms even further. And you'll see why I'm doing that in a second. 5 over 2 nr ln of u minus, because natural logarithm, the rules say that ln of u over an plus bv is equal to ln of u minus ln of an plus bv. So I'm going to say minus 5 over 2 nr ln of an plus bv, right, is equal to, I distribute this nr but not that 5 over 2, or plus rather, nr ln of v minus nr ln of cn, okay? Cool, that's this whole thing here. Now, I'm holding u and n constant, right? And I know that a, b, c, and d, or a, b, and c, and r are constants, right? I only see constants in this term, meaning that that whole thing is a constant, and when you differentiate a constant with respect to anything, it goes to 0. So I can immediately cross that out and say 0, right? Cool. Do I see any just constants anywhere else? Yes. Just u is here, and n and r, those are all constants, and 5 over 2 0. So I'm left with this, right? Cool, let's differentiate this with respect to v. So I'm gonna go ahead and say that p over t, because this is equal to p over t, is equal to, let's differentiate this. I can pull out 5 over 2 nr. The differential of ln, I can't just cross that out. That's a v right there, right? So the differential of ln is going to be 1 over an plus bv, right? Cool. Now, but there's a chain rule involved, right? You take the differential of this and multiply it by this whole thing. So this would go to 0 if I'm taking the differential of that. This would turn into b. So b times this whole thing just equals b over this, right? Cool. So that's nr times this. This is times. Plus nr, I can pull that out again, times 1 over v, right? That's that, right? Now, I'm just going to go ahead and sort of combine these. Negative 5 nr. Is this correct? Let's find out. nrb over 2 times, let me just do this, negative 5 over 2 times nrb an plus bv. I don't want to start putting brackets, extra brackets inside and everything. Plus nr over v. Is this plus? Yes, they gave me a plus, right? Yes. Yes. Okay, cool. So we're left with this, right? So p over t equals that whole thing, equals negative 5 over 2 nrb over an plus bv plus nr over v. Now, if I want to just get p, right, I can multiply this whole thing by t, right? Yes. So p is equal to, now if you were lazy, you could just write t times, and I guess put one big bracket around, or 2 big brackets around the whole thing, and say that's my p, I'm finished. But I want to show you something. So it's negative 5 over 2. I'm going to say nrt. I'm going to say 5b over 2 times nrt over an plus bv. And the reason I did this is because our fundamental ideal gas equation, right, says PV equals nRT, right? My P would be equal to nRT over V, right? Cool. Doesn't this sort of look like, I only see constants here because I'm holding my N constant, nRT over V, right? Yeah, like, yeah, right? Cool. This would give me plus nRT over V, and that's literally what I just solved for, right? Cool. So we sort of know we're on the right track. We can sort of say that, oh, we've solved for this in terms of T, V, and N, right? Everything else is a constant in here anyway. So let me just double check if this is correct. Yup. So this ends up being your final answer. And that's when they're asking you to solve. So let me just say P as a function of T, V, and N gives us this. So that's really all there is to it. I was so confused by this at first when I saw it, and then I just thought like, hey, like, yo, this really makes sense. Like, huh? Like, this really makes sense. So, I mean, maybe like see what they give you, see if you can sort of just manipulate. When in doubt, fundamental first and second law combined. So like, if I didn't make anything clear, please feel free to ask questions in the comments. Express your concerns there. And please don't forget to like and subscribe. I think this can sort of help out with, like, I think they do things like this sort of in physical chemistry too. So if you have chem major friends, let them know. Yeah, and let's keep learning thermo, okay? All right, bye-bye.